Hey, Mr. M here. We're going to talk a little bit about population growth. Populations grow depending on the number of births, deaths, and the movement of organisms into the area, which is immigration, and the movement of organisms out of the area, which is emigration. It makes sense then that if the number of births are greater than the number of deaths, then the population will increase. Populations tend to start off growing slowly, and they continue to double. And if there is a constant birth rate and unlimited resources, the population graph will have a J shape. Yet, in most real populations, food and disease and other resources become important because the conditions become crowded. There's an upper limit to the number of individuals the environment can support, and this is known as the carrying capacity. And the shape of the graph in this case is an S. Have you ever been on a bus and noticed the carrying capacity sign up at the front? It lets you know how many people can fit on that bus, the maximum amount that that bus can hold. We sure wouldn't want this situation to happen. On the graph, the carrying capacity is the part of the graph where it is leveling out, because all populations at some point in time, they're going to start running out of resources. Now, if the graph was really going completely straight across, then that would mean that no organisms are being born or none are dying. So let's zoom in to see what's really happening here. When you get to a point where the environment cannot support the population, some organisms will die. If the population numbers fall below the carrying capacity, then there is room for more organisms. This continues over and over and over so that when we zoom out, it looks like the graph is going straight across. That's it. If you think you have a good grasp on population growth and carrying capacity, then go ahead and stop the video. Otherwise, watch for another, I think it's 30 seconds or something, and see an example with fishies. Okay, so here we have a fish population, and if you look on this thing up in the upper right, it tells us we've got two fish. And so we've got a birth rate of 1.5 and a carrying capacity of 1,000. So let's mate some fish. So I'm just going to click the step button here. So now we've got 4, and as they continue to mate, notice the number of the population in the upper right keeps going up. All right, so right now when we look at that graph, notice it starts off really slow, so it almost looks like it's almost even straight across. So we're going to continue, keep mating these fish over and over and over. So now we're at 220. Now let's take a look at the graph again. You can notice now it starts getting this J shape. Now in this window though, the fish aren't going to be able to mate forever. They're going to run out of space, and so that would be the carrying capacity. So in this instance, I set the carrying capacity at 1,000 because only 1,000 fish will actually fit in this window. So I'm just going to step it up real quick. And we get to a point, and we are, notice we're full. Now notice the population says 999. Okay, that's because some are being born, some are dying. So no matter how, I can click on this thing forever, and it only stays at 999. Now if we take a look at the graph, look, notice the graph is going straight across. That's carrying capacity.